In this example, we are going to use a new method for doing our limit, L'Hopital's rule, but I need to make sure that I have the right scenario for this. I need to have kind of a 0 over 0, 1 over 0, infinity over infinity kind of situation with this. So if I plug in a 0 here, I'm looking at that goes away. So square root of 9 is 3 minus 3, I'm getting a 0 on the top, and I get a 0 on the bottom. So I have that. So I don't have to multiply by a conjugate. What I can do instead is I can do the limit as x approaches 0. I'm going to do the derivative of that. I'm going to get it ready to do the derivative. Okay, so I rewrote it so I can do my derivative. So I'm going to do the derivative of this and still be doing a little limit. So I have a 1/2 that's going to come in front. I have a 9 plus 3x raised to the negative 1/2. There's the chain rule, and there's the derivative of the outside times the derivative of the inside, which is 3. And then when I do the derivative of that 3, it's going to go away, and then divided by a 1. All right, so I know I don't have, if I plug in 0, I don't know what it is yet, but I know I'm not going to get a 0 in the denominator. So I am done doing L'Hopital's rule. Now I can plug it in and actually find out what my limit is going to be. So if I do that, let me maybe rewrite this here a little bit, that I want to plug in 0. I have 1/2, so I'm going to start to just kind of clump this. I can drop this 3, or drop the denominator of 1. So I have a 3/2, and then that is a square root that's going to go into the denominator. Okay, now I'll plug in the 0. So we have a 3 on the top. We have a 2 times the square root of 9 plus 3 times 0. And that is going to work out to be 3 divided by 2 times the square root of 9, which is times the 3. That 3 can cancel that 3, so we're looking at a 1. So that is our limit on that problem.